Building retuning training was conducted by Ron Underhill and Gupong Liu, scientists at the Pacific Northwest National Laboratory. Classroom and on-site training for Maryland State Agency facility managers was conducted at Towson University in Towson, Maryland on June 17th through the 19th, 2014. This segment of training covers minimum-maximum outdoor air operation.
Minimum outdoor air. Best time to economize, we say, is between 40 to 60 degrees outside. Now, if you're concerned about humidity, enthalpy, then if you're strictly basing your economizer based on outdoor air temperature, 60 degrees for most climate zones, up to 60 degrees. Once you get below 40, you're worried about freezing. You can still economize, but you don't want to be bringing in 100% outside air. If you're out on the western part of the United States, we can economize with outdoor air up to 70, and I've seen some places as high as 75 degrees because it's so dry. See, we should be able to figure out a way to box the dry air and ship it out here, right? Okay, the approach, with your BAS, if you've got mixed air, outdoor air, and return air, you can calculate outdoor air fraction. It may or may not be accurate, but we generally find don't do this on rooftop units, but if you've got large air handlers and you've got accurate instrumentation, mixed air, outdoor air, and return air, you can come up with a pretty accurate outdoor air fraction based on temperature and compare that to your damper, command, and time of day. And see if your outdoor air fraction indicates that, you know what, you might be bringing in way more outdoor air than what you really think your system is saying you are. And sometimes this last bullet can tell you if your fan speeds are tracking for air balance issues. So these are some of the things that you could use with the outdoor air fraction calculation. We recommend coding it into your BAS, at least for larger air handlers. Do I have too much ventilation? That may not be a good thing when I could be on some prescribed minimum. So too much outdoor air could be a bad thing unless you're economizing. Too much outdoor air, if you're bringing in outdoor air at nights and on weekends and warm up or cool down periods when no one's in the building, and you decide to still use your minimum control. So again, there's the equation. It's real simple to code in. And it might be something that you want to do for public buildings or schools along with CO2 if you're trying to validate indoor air quality issues. And it may highlight that you got a failed economizer, failed damper, failed actuator, which has happened for us, by the way. So the reason why we recommend that is because 20% damper command on an economizer never is 20% outdoor airflow or fraction. You've got pressure drops across dampers. Your return fan is very little pressure drop, especially for plenum systems, while your supply fan is trying to move air across coils, filters, and dampers. So no differential pressure, no flow. High differential, you could have high flow. If I have a temperature sensor right in this area, measuring mixed air, return, and then outside air, I can get a pretty good idea what the true fraction of air is. Again, caveats to this, it assumes that your mixed air plenum is working. It assumes that your return fan is working properly in conjunction with your supply fan if they're VFD driven. Otherwise, highly recommend CO2 sensors. And again, the problem with CO2 sensors is if I'm infiltrating, my building's negative, my CO2 sensors in spaces can still read relatively low. How many, those of you that have CO2 sensors, demand control ventilation, how many of you have algorithms that are set up to, there's two thought processes, well there's a lot of thought processes in ASHRAE, and I'm not going to go into details, but how many of you have CO2 that's a control that says if I exceed some value, we'll just say 1,000 parts per million, I'm going to bring in up to 100% outside air. Anybody?
It will gradually start to open to get that level back.
Yeah. So the thought processes are, from personal experience, I can tell you once you hit 1,000, if that's your magic point, it would start incrementally opening or overriding your minimum, bring in more outside air, bring in more. I'm still at 1,200, 1,300, and we found when we're talking about the needle, the meter, going back looking at a building that was electrically heated or gas steam heated. Wow, what happened to our building? We were doing great. Everything was, now all of a sudden we see our heating costs going way through the roof. CO2 sensors also need to be calibrated. And if your control algorithm is such that it says, you know what, once I hit 1,000 or whatever, all bets are off. I'm bringing 100% outside air. You just turned your economizer system, your air handling system into a 100% outdoor air system. Real expensive. And especially if it's in the wintertime, you got to heat all that outside air based on a fault sensor. So we limit ours to no more than 30%. That's another strategy. Again, ASHRAE and what does ASHRAE really say and arguing about it. At this point, I really don't care what ASHRAE says. I'm really looking at the fact that I've got a building. If I got a CO2 sensor and I'm 100% outdoor air damper and I'm not bringing that down, wow, maybe I should go look at it. If I've got a CO2 sensor and I hit 1,000, do I alarm it? I've seen a lot of CO2 sensors with no alarms. And if my control algorithm says bring in 100% outside air and I'm not alarming that, ooh. So, because that can be real spendy right there. Any questions on that? Just some charts again that eChem generates based on time. This is about 5 days, 4 days. But you can see the outdoor air fraction is the red line. The outdoor temperature is the blue. And the actual damper command, this is from one of our buildings back in 2007. And as it warms up to 60, you can see we go to 100% outside air. As we start tracking down below 40, we reduce that. We're still bringing in outside air. For the most part, this tracks. Another air handler. This one has a schedule. The one before ran 24/7, and we can see when it shuts off about 6 p.m. to 6 a.m. or whatever. Again, it tracks the outdoor air fraction. Calculations are problematic when fans are not moving air, so take it with a grain of salt. And this is just not an outdoor air fraction, but it's the damper, which is the green line, and the outdoor air temperature. And this basically says, based on this scale right here, for the damper, outdoor air temperatures on that axis, 30% is my cutoff point. I'm not going to go any lower than 30% outdoor air. I was asked by someone about 100% outside air systems. Some of your colleges, some of your labs are 100% outside air. You have vivarium spaces with animals, and they're a totally different animal. We don't cover those types of systems in our training. Most of our training is focused on commercial buildings with economizers, return air. But I will say this, we have a lot of experience with 100% outside air systems. Generally, they run 24/7. High energy costs because you're bringing 100% outside air to temper that air. Winter, summer. High filtration costs because you're bringing in 100% outside air, which may be dusty or whatever.
Usually humidity control, though.
Humidity. Yeah, so just a lot of challenges. I'll just say that. So number one, do you have a heat recovery system on those 100% outside air systems? And most people are shaking their head yes. Whether it's a runaround loop, a heat wheel, that's your number one energy saving feature, and very few people check it for performance. And when I say check it, what was it designed for by the engineer, design engineer? How many BTUs, how many degrees delta when it's really cold out, really warm out? And do we track that? Again, we've got a BAS system that we can track incoming and leaving temperatures across heat recovery coils. We have a lot of lab type systems. We're a national lab, as I said earlier. We do a lot of biological, chemical, and radiological research. Therefore, we have a lot of 100% outside air systems. And we found one of our buildings, the heat reclaim system, runaround loop, was designed for about 20 degrees delta. So if it was 40 degrees outside, we could pick up 20 degrees and get 60 degrees leaving the fan. If it was 20 degrees outside, we could get up to 40. We've had problems, and I won't go into a long story other than to say the performance of that system degraded to about 5 degrees. So we had a huge amount of 100% outside air that we were having to heat, and it ran 24/7, 150,000 CFM of air. And finally, one of the facility engineers said, we got to look at this, and through a process of elimination, and I would call it retuning because it wasn't recommissioning, it was just saying, hey, why is it not running right? Here's what the specs say. And just systematically going through it, they found several problems. The pressure of the hydronic loop, they had leaks, they fixed the leaks, so on and so forth. They got it back to where it's operating and got about 22 to 25 degree delta, which was even better than what they had by the specs and the design drawing. So, needless to say, they significantly dropped their heating energy loads in the wintertime. It's able to do some cooling in the summertime, but a lot of benefits, but it means paying attention to that particular system. So anybody who's got heat wheels, run around heat recovery loops, I hope you're paying attention to them. Use your trending capabilities. Very important. Other than that, is there any other opportunities with 100% outside air? If it's VAV controlled, meaning I got VAV boxes, most of them are probably going to be constant volume. They're just going to maintain or modulate the damper in response to filters loading up. We have seen some hospitals do night setback. They don't shut the fans off. They keep ventilating. They just go to a reduced airflow at the individual boxes, kind of like what Gupong was talking about earlier. And it's all based on scheduling, which is very simple to implement. And so the fans keep running. We keep tempering air, providing 55 degree air, 65, whatever the reset says. We just see that the boxes go to some reduced value at non-critical zones, probably admin areas, hallways. We still have to maintain airflows and pressurization issues. Those are probably the same issues that you would have in your vivarium spaces and your lab spaces. Did I answer any the questions about what opportunities might be available for 100% outside air systems? Maintenance. Keep your filters and coils clean.